What's going on, guys? Welcome back to the MG YouTube channel. I'm Malachi Greb, CEO of Elite Automation, Elite Properties, and an investor in Tesla. Well, this week we got some big news. Elon said that we are basically going to get a 10x parameter update on our FSD. So not only is this a big deal for users of FSD, so if you own a Tesla and you have FSD, you're about to get a pretty significant upgrade of your FSD. And I want to dive into like what this 10 parameters means. I want to talk about what it means for you as a user, what it means for you as an investor, and what it means for Robotaxi. And then I also want to dive a little bit deeper into like what parameters actually are. You may get a little bit technical. However, it'll still be very generalized because honestly, it's very complicated to get extremely technical whenever it comes to like things like parameters, and I'll get into that in a little bit as well. So first of all, you're just going to see as a user, you're going to see a huge change in your FSD as far as how well it operates. And as you know, if you're already in version 13 and you are using hardware 4, it's extremely good. And just going from version 12 to version 13, it's tremendously better. And we're basically going to see a step change that is at least as good as going from 12 to 13. So if you've seen how good it was going from 12 to 13, I think once we go from this 13, they're probably going to call it 14. I don't think it's going to be a 13 dot anything. I think they're going to call this one version 14. And I've been kind of predicting that one for quite some time now, and that we are not going to get another version of FSD until we get version 14. And the reason why is because they're focusing on version 14, and they don't want to waste any more compute power on trying to get version 13 ready. Also, as a Tesla investor, you know that they're doing Robotaxi. Robotaxi is scaling up right now, and so their engineers are highly focused on Robotaxi rollout and any manual modifications and stuff they have to do to make the Robotaxi work in the areas that they are currently working in. So they're either having to do manual training or some type of manual coding and whatnot to like round out all the edge cases that they're seeing. So there's a couple different things that happen with that, which is a little bit off of the topic of the parameters. But if they're manually training stuff and then they put that back into the main model, you automatically get those upsides. But then parameters is a totally different thing, and I don't think that Tesla is running with these new parameters. I don't think it's even ready for the Robotaxi vehicles right now. So it's not like we are just getting this 10 parameter update or the version 14 update, but the Robotaxis will also get this version 14 update. So that's one of the things that I want to talk about. So Robotaxi is already operating in Austin with a safety rider only. So once we add the new parameters, it's just going to make it that much more smooth. So I really can't discuss a lot more with really starting digging into like parameters and what parameters means. So the easiest way to look at a parameter is like a unit of measure. And so a unit of measure could be many different things. A unit of measure could be the same way that you would measure the distance from something, you'd measure the weight of something. Each one of those has its own different measurement. So you have like this weighs this many pounds, or this is going this many miles per hour, or we're going this many feet. So all these are different units of measure. So whenever you have something like a parameter, it's that unit of measure, and then you also have to think about the scale of that measure. So let's say, for instance, another easy example. If I measure something by color, you still have color, and color is, I'll say, like one parameter, but within the parameter of color, there's a matrix. And so what does that mean? Well, you have blue, you have red, you have yellow, and so each one of these is like a parameter, okay? And then you take this to like a next step, and again, it's a matrix. So if you need to know anything what a matrix is or a data matrix, then this will make a little bit of sense. But you have like your dark blue, your light blue, your regular colored blue, your all the different names of blues. I don't know colors all that well, so and same with your reds. You have your reds, and you have your light red and your dark red, and all these different colors, right? And so each one of these is a version of that matrix. So again, you have color as the parent, then you have, your basic color, like blue, red, yellow, and then you have like light of that color, dark of that color, and all the different hues in between. So like that's just an example of like in a matrix of color. And then there's other things there that could become units of measure inside of color as well. Meaning you could have, like, let's say for instance, you could associate mood with a color. Okay, yellow is a happy color. Blue is a sad color, right? Red is an angry color. And so those are also other parameters that would be associated with color. Now, I'm just giving you kind of a general example to break that down as much as possible. So how does that convert over to, autonomous driving? Well, with autonomous driving, it could be something like, the degree angle at which you're turning the wheel, right? It could be the amount of acceleration that you're putting in. And also, since Robotaxi or since autonomous vehicles are in motion, you also have your present and future and past, right? It's a moving object through space and time. So a huge thing that will help out, with these parameters is the ability to see into the future, right? To predict outcomes before they occur. So not only could you process the information you see now and execute on the information that you see now, but you can also predict information into the future and run a simulation of what those outputs may look like, right? And again, it's not going to be able to have like any like true confirmation. It'll only have like simulated confirmation, but they could run some type of simulated confirmation. And so, basically going with that 10x parameters, or anytime they're adding parameters, it's basically giving them the ability to have more data matrix, meaning it's almost like the equivalency of going from having white and black colors, like white and black TVs, and then all of a sudden we got color. Now we can visibly see color. So just imagine a world where you can only see in white and black, and then all of a sudden you can see the world in all these different colors, right? So that same type of a thing is happening whenever you are increasing your number of parameters. And the parameters that we're currently using have already gotten us to the place that we are in now, right? FSD is as good as it is now, sitting on the current amount of parameters that it has. So by adding parameters, you're going to add the ability to analyze more things. And since we've already analyzed to the point we're at now, I think most of these parameters here, now that we're 10xing, so you're gonna have 9x parameters that are pretty much entirely going to be used for edge case, and there'll be like some amount of them optimize or to optimize what is, I'll say, currently executing, right? Because even though like 99.9% of the time FSD executes properly, let's say for instance it's already analyzing different future scenarios, right? And in those future scenarios, it runs that simulation and it gets feedback. And let's say for instance 8 of the scenarios come back, or let's go like this, let's use a number of 20. There's 20 simulation scenarios. It comes back with 13 of them are good, no crashes, no negative conditions at all, right? And then 7 of them come back with potential issues, right? Like, oh, if we go with that route, then this will happen, that'll happen. And I'm not just talking about necessarily what would happen in the physical world, but even things like coming back and say like maybe the data's corrupt, or I couldn't make a decision, or anything like that, right? So, with that being said, even with the current model that's running, or not necessarily the current model that's running, but even with the current parameters we're running, you can add more parameters on top of those as well. And then that will make it so that you go from like 13 of them being good and 7 coming back as unknown, bad, whatever it may be, to now we're at 16 of them are coming back good, bad, whatever. And even if we're going with 10x, it could be a plausibility that we're going from 13 good to now it's going to be 18, 19 good. Because again, it's really going to add parameters to where there's potential edge cases, right? Again, I keep mentioning this on every video because I really want like Tesla's engineering team to either respond to it or implement it. But there needs to be a confidence scale where basically the FSD is giving some type of information on how confident it is in the decision that it's making, and then they can pass that off to teleoperators if ever that confidence rating drops below a certain amount. AKA at 50% confidence level, it immediately emergency alerts a safety operator to jump in and start troubleshooting what's going on with that particular Robotaxi. But like, let's say for instance, if it's at 70%, then it's a low priority, and then they're not worried about it. So with that being said, that same way I was saying that 13 and that 13 of them coming back good out of 20, well, let's say for instance if 13 of them, that could be part of that confidence scale where 13 came back good, and I'm like, ooh, I'm not that confident, right? Only I got 13 out of 20. That's not very good. It's kind of actually failing whenever it comes to analyzing data. It's close to 50%. So like with these new parameters, it may keep that confidence scale up to where it's pretty much always 80%. Right? So then anything that drops below 80 then becomes, oh, we need a teleoperator in there now because this is a condition that FSD is kind of struggling to understand. And again, like this, this won't be able to be used in high-speed operations as near as much because you have speed, as a factor, but it will work out well as like in parking lots. So if it's like stuck in a parking lot and kind of struggling to make a decision, it's like immediately queuing somebody back at the teleoperations center to jump in and basically need to teleoperate or add a new destination or manually drive the car or whatever they need to do to get the vehicle out of the situation. Okay it to give gas to move forward, or manually put it in reverse so it can start trying to do a reverse function, whatever that may be, right? So going back into the parameters and like having I want to kind of retouch on like the colors again. You have the colors, you have light and dark, and then you have like your things that are again like a happy color, a sad color, all these different things, right? So with FSD, you have like those similar situations in the fact of let's say for instance I see a pedestrian on the side of the road, okay? Like Robotaxis are pretty sensitive about, or FSD in general is pretty sensitive around pedestrians on the side of the road. So one major thing that FSD can do is analyze, is that human walking towards me? Are they facing away from me? Is their body turned the other way? So think about it like this. I'm going to break this down because this is very applicable and it's still going to be kind of generalized. Okay, think about you have a human. The human's standing this way, a human's standing that way, and the car's over here, right? Car's here. So human standing this way, human standing that way, human standing that way, right? Let's say, for instance, as of right now with the current parameters, all it can detect is if they're standing in like north, east, south, west, right? That's all that the FSD kind of knows. However, with this new parameter, they could essentially be able to tell what angle they're at. So they can only predict, like, again, basically what quarter of an angle they're in, or what quarter of a circle they're in, right? Whereas now with this parameter increase, you can now tell where that human's standing in a 360-degree angle. Okay. Another thing to add to another like matrix or parameter level is, can you detect where the human's body is versus where their face is at? So like again, if I'm standing here and I'm facing the car, and my head's turned away, now I'm a human not paying attention. Or let's say for instance my body is facing that way, right? I'm gonna kind of just turn around and then I'm gonna look back like this. I can detect that the body is facing away, the human's looking at me, so I see a face. So the second scenario is not necessarily a risk. It's not necessarily something I need to slow down for, because the human is not coming my direction, the vehicle. So as the human's not coming towards the vehicle, so the vehicle doesn't need to worry about them. However, in the other scenario where maybe it can detect the human's head is turned and it's walking straight, that might be more critical, because maybe they have their head up their ass, or maybe the phone's down, or head is down in their phone, right? Boom. That's going to happen all the time, right? So for like a parameter to be able to pick up something like human holding phone texting, we need to be extremely cautious, right? Or versus like somebody standing there, chin high, looking forward. Again, like this is getting very deep, and will it analyze, humans on the side of the road that much? I don't know. I mean, that's pretty deep stuff for it to be able to analyze something like that. In the future, will it? Yes. Yes, it definitely will. Why? Because if you're going to make FSD as best as it can ever be, that's how you do it, right? Because first you make it as safe as you can, right? And then after you make it as safe as you can, and again, nobody ever dies because it's so safe, now what do? Now you speed it up, right? Because you got to optimize on it. You're always trying to make it better. So how do I drive past pedestrians and do so in a way that's safe, where nobody ever gets hurt or injured or whatever, right? You can't just always say, oh, we'll always go slow by pedestrians because that's the safest thing to do. Well, it is the safest thing to do, but we can also do things like analyze, like, what's that human doing? Like, if everybody's back is turned towards the road, do you really need to slow down for that pedestrian just because there's a pedestrian sitting right there on the sidewalk? And there's some other oh shoot, I just lost it. There's some of the edge cases where like there is ever like a phantom type of braking or something like that. It's generally because there's a human or something standing on the side of the road, and it's like, whoa, and tries to slow down or tries to stop, and it's like just being extra cautious that like it sees a human there, it might even be facing the other way, but it just ignores it. One other thing that's there with parameters is something called weight. And so weight basically gives priority to different parameters, right? So if I have a green light here in front of me and I have a human walking out in the road, is a higher weight parameter than the green light. And also too, what I got to be careful not to say that so binarily, because whenever something is weighted, it could take up more than one parameter, right? You can have multiple parameters that's weighing the scale of the importance of this thing. So it's not that it's just set as a hard priority. There's decisions that have to be made to make it a high priority, right? Again, going back to the scenario where I was saying somebody's head turned away, or is somebody's body facing towards the car and their head is down, those are perfect scenarios of where a neural net, or where the parameters are extremely important, because those parameters give you the ability to make these decisions of human's head is down, human is facing car. Whereas, like, again, going back to the same example, now you can maybe only tell like where they're at a quarter of a circle. Okay, so the parameters is going to open up the ability to analyze things a lot better. Now, one thing that I don't really see with FSD right now that I'm very surprised it's not there, and I don't understand how it's a parameter constraint. It should not be a parameter constraint at all, and that is signage, right? There's no reason for FSDs to not be able to read a sign, know what it says, and then be able to perform on that action, like no left turn or no right turn, or what is it? The school signs flashing when children are present, right? So reading text is not a hard thing for AI to do now. So I don't understand why it seems like FSD is not looking at those things at all, because like it never slows down for a school zone. And signage reading is not that complicated. However, if you go back to parameters, something like reading could potentially consume a lot of parameters. However, if you compare that to something like we've recently seen where basically FSD can stop for a toll, and you can pay for the toll, and they can recognize that interaction and then let you go. I don't understand how AI could detect that interaction in all the different the parameters that would need to be used for that interaction, yet not be able to read signs and be able to determine what signages say. One of the next things that I think has to be there, but I don't know if FSD is even set up remotely to be able to do this, but is memory. So FSD should hold some memory to make sure that it executes things better the next time, right? And I know we're going generalized and we're trying to make FSD work the best for the first time, but if you take anybody, the best driver in the world, and you drop them off in the city they've never been, and the turns are different, and signage is a little bit different, and lights are a little bit different, and even I've traveled the world, right? And I've been to places where it's very common you're just driving down the road and there's U-turns. Whereas my hometown, U-turns are not that big of a thing, or they're almost kind of frowned upon and looked at as a bit illegal or whatever. But you go to some cities and it's U-turns are just what you do. You can't survive in the city if you don't do U-turns. But so going back to it, with memory, you can read a sign. Even if you read a sign and you read it too slow, aka when I say you, the car reads the sign, it reads it too slow to be able to react to it. If it has memory, it can react to it next time. It can store that in its memory and say, geographically, here's where I'm located at. I'm getting close to that intersection. It should be very easy, intersection to intersection. Oh, I've been to this intersection before. This is a no left turn intersection. I seen it last time I was here, right? And so it's able to basically pull up that archive of memory and talking about weight. Maybe it's not weighted fully, right? Maybe a lot of the weight is still what do I see today? Because you'll need that for things like construction. The construction will disappear, or maybe there's new construction there that wasn't there before. But even with construction being there, with the neural net, and if they can update the database immediately or relatively immediately, if there was construction there today and then I drive by it tomorrow, the following day, and I drive by it tomorrow and it's gone, the following day, it can maybe even do a confirmation. Is that construction gone that I seen the 2 days prior? Yes, it is. Okay, boom. It puts it out to the cloud. Hey, all Teslas, there's no longer construction in this area anymore, right? And so then any other Tesla that drives through that area now knows that there's no more construction in that area. And basically the same way that Google Maps updates and pings, hey, there's construction in this area. So you see Google Maps update with the construction thing on the map. They could basically have that same thing with FSD and then say, hey, it pings all the cars and says, hey, if you're when entering that area, there's construction in the zone, proceed with caution. And then from there, it can also feed, hey, another Tesla went through this intersection a few hours ago. Here's how they handled it, and they got through with no interventions or anything. And they could pass that information to every other Tesla, so every Tesla that passes through that area knows exactly how to handle that area without any issues. And again, as soon as anything changes, that Tesla then sees that change, passes it to the fleet, and then can basically kind of have that hive type of network. Now it can only do that through memory. So at a bare minimum, the memory needs to stay with vehicle. So even if it doesn't pass that information to your vehicle or the guy next door's vehicle, at least your vehicle's seen it once, and if it sees it again, then it can learn from it. And I'm talking about construction, I'm talking about signage, and then one other thing I want to say is things like pulling into your driveway. Why can't I pull into my driveway 1 or 2 times, and then now, or even if I got to pull into my driveway 10 times, whatever, cool, I'll pull into my driveway 10 times. But after that 10th time, my vehicle automatically knows how to pull in the driveway the same way I do every time. Or whenever I put home on my GPS, it asks me, front of house, or driveway. Okay, if you've ever used GPS going to the airport, it tells you, are you going to pick up, are you going to drop off? So you search like the airport name, and then it says pick up, drop off, international, domestic, right? Your every location you go to should have that type of pop-up where it's if I click home, it asks you driveway or front of road, right? And then boom, you click it, and it even after you've been in your driveway slot 1 or slot 2, right? For the different park locations. So if you have I'm saying if you had like a 2-car driveway, if you have a 3-car driveway, slot 1, 2, slot 3, okay. And it can also lot out the front of your drive too, because it can measure. Okay, here's your edge of your driveway. Here's the front of your house. You have the ability to park 4 cars in the front of your house. Slot 1, slot 2, slot 3, slot 4, right? And then that gives basically the ability to park exactly where you need to park at. Another primary example where this is especially useful, I think, for Robotaxi is like going through the drive-through, right? So like you could have the option to have your multiple stops, and like maybe it's you select Starbucks, okay? Starbucks, okay, then it pops up drive-through, park, or I don't know what your third option would be, drive-through or park. And so if you select drive-through, it'll drive through the drive-through for you. It'll stop and wait at the talking kiosk thing, right? And then it'll go to the window to pick up your food, okay? And then it will be able to drive off. Parking, if you hit the park option, it'll park for you. You'll be able to go inside, do whatever you're going to do, go back out to the car, and then be able to take off again. So these are things we're going to want to have because, like, say, for instance, you don't want to go to Starbucks, order your coffee, and have to hail another Robotaxi. You want to be able to jump back in the same Robotaxi you're in. Maybe you have luggage with you. Maybe you have your backpack with you, or just if you're like a working individual and you're working through the day and whatnot. And again, talking about trying to reduce the expense so everybody's using this on a daily basis. Think about if you're a salesperson. Maybe you want to use Robotaxi, and like basically that taxi is going to be assigned to you for the entire day. And so you can have a way to assign to you for the entire day, but you need to be able to interact with that vehicle to pick up and drop off and all these good things. Also, one other thing that I think should be in Robotaxi, I don't know like where this plays out with like safety regulations and everything, but give the rider the ability to have some controls of the vehicle in the car. So whenever I enter a car, I can actually at least give some commands, like talking about like the drive-through. If I go to pull up through the drive-through, if I'm too far back from like the speaker thing, I can say inch forward or something, like inch forward button, and then it'll go inch forward and be exactly where I need it to be. I just think that would be something very, very useful into the future. Or like, say for instance, if the vehicle's stuck, instead of having to have a teleoperator fix it, like I'll just fix it right here. I'll just go back, forward, and then it'll be fixed, done. You know what I mean? And then if you take over controls and you're the one operating that car, you have liability of that car. Versus like just letting a teleoperator chime in and be able to, operate it for you. So hopefully, like this is kind of a good breakdown of parameters. Parameters are something that are very confusing. And to be honest with you, one thing about AI is I think even the AI engineers do not know what's going on inside the AI. They're like, hey, we give it this raw data. It does these things afterwards. And then we just tell it whether that was the right thing to do or not do, right? And then from there, it just kind of keeps restructuring its code and neural nets to adapt to like the things that we say yes and no about, correct or incorrect. And so therefore, inside the net itself, we can't do much. Tesla can't do much. They can only like expand the parameters and then just hope it captures anything that we see. So like that way, whenever I said, nope, this was not good, instead of recording, or instead of recording, let's say, 5 billion data points, it can record 50 billion data points. I'm using that 10x reference. So, that's just a couple of ways that it can, it can be used to like basically like train the data, and that's how I think that they have to do it. I don't think they have any other choice. So like just as it expands the brain, it's like taking a child's brain and then going to version 12, we went to a tween's brain. Going to version 13, we went to like a almost adult, a teenager brain, and then we're gonna go to version 14 to an adult, a young adult brain, and then we're probably gonna go to version 15, and we're gonna be at a middle-aged adult. We're gonna go to version 16, and we're gonna be like the wisest guy on the block. But yeah, so if this video was useful for you guys, if you thought this was a good breakdown of parameters, or if you have any other questions, drop it down in the comments below, and subscribe for any other Tesla related content and or business and entrepreneurial content. Catch y'all on the next one. Peace.